Hello dear students, shall we discuss a few more organic name reactions? Yes, let's get started. First one, Hofmann-Bromamide degradation reaction. In this reaction, a primary amide is converted to a primary amine. A primary amide is converted to a primary amine on heating with the bromine in the presence of sodium hydroxide or potassium hydroxide. Okay, in the presence of NaOH or KOH, when a primary amide is heated with the bromine, it is converted to a primary amine. And the peculiarity of this primary amine is that it has one carbon less than the original. Okay, primary amine has one carbon less than that of the primary amide. Okay, let's write an example. CH3, CH2, CONH2. CONH2. This is an amide. This amide is heated with the bromine in the presence of sodium hydroxide or potassium hydroxide, and this gives, when it is heated, this gives CH3, CH2, and this CONH2, this will become NH2. Okay, CH3, CH2, NH2 plus KBr plus K2CO3 plus H2O. These are the side products. Okay, so when an amide is heated with the bromine in the presence of potassium hydroxide or sodium hydroxide, then it is converted to a primary amine containing one carbon less than the amide. Okay, and potassium bromide, then potassium carbonate K2CO3, and water is obtained as the side products. Okay, this reaction is called Hofmann-Bromamide degradation reaction. Next one is Clemmensen reduction. In Clemmensen reduction, aldehydes or ketones are reduced to corresponding hydrocarbon. Aldehydes or ketones are reduced to corresponding hydrocarbon. Aldehydes or ketones are converted to hydrocarbon in the presence of the reducing agent zinc amalgam and concentrated hydrochloric acid. In presence of zinc amalgam and concentrated hydrochloric acid, aldehydes or ketones are converted to hydrocarbon. That is, aldehydes or ketones contains the carbonyl group, that is C double bond O group, and carbonyl group in the presence of zinc amalgam and concentrated hydrochloric acid, the CO group is converted to CH2 group, that is corresponding hydrocarbon is obtained. For example, if we take a ketone CH3COCH3, when heated with amalgamated zinc and concentrated hydrochloric acid, the CO group is converted to CH2 group. So it will be CH3CH2CH3. Corresponding hydrocarbon is obtained by Clemmensen reduction. So this reducing agent is very important here. Zinc amalgam and concentrated hydrochloric acid. For Clemmensen reduction, reducing agent is this one. Okay, aldehyde or ketone is reduced to corresponding hydrocarbon. Okay. Next one is Wolff-Kishner reduction. In Wolff-Kishner reduction also, aldehydes or ketones are reduced to corresponding hydrocarbon. But here the reducing agent is different. Reducing agent is hydrazine and potassium hydroxide. Aldehydes or ketones are reduced to corresponding hydrocarbon in the presence of the reducing agent hydrazine. Hydrazine is NH2NH2. This is hydrazine, and potassium hydroxide in presence of ethylene glycol. Okay, NH2, NH2 hydrazine, potassium hydroxide and glycol. Aldehydes or ketones are converted to hydrocarbon. So here also the carbonyl group C double bond O group in the presence of this reducing agent hydrazine, KOH and glycol, CO group is converted to CH2 group. Okay, just like Clemmensen reduction, the reduction takes place but the reducing agent are different for Clemmensen reduction and Wolff-Kishner. In Clemmensen reduction and Wolff-Kishner reduction, aldehydes or ketones are converted to hydrocarbon. But in Clemmensen reduction, amalgamated zinc and concentrated HCl is used as the reducing agent, while in Wolff-Kishner reduction, hydrazine, potassium hydroxide and ethylene glycol is used as the reducing agent. Okay. Let's write an example. CH3CHO. CH3CHO on reduction on Wolff-Kishner reduction. KOH, glycol. So here CO group is converted to CH2 group. So this will be CH3CH3. Corresponding hydrocarbon is obtained. Okay. Next is Rosenmund's reduction. Rosenmund's reduction is the catalytic reduction of acid chloride to aldehyde. Here acid chloride is converted to aldehyde or reduced to aldehyde. And which is the reducing agent here? Palladium and barium sulfate. Palladium and barium sulfate poisoned with quinoline or xylene. Okay, in presence of palladium, barium sulfate, acid chlorides are converted to aldehyde. For example, an acid chloride. Acid chloride, what is the functional group? CH3COCl. Okay, COCl. And the COCl group is converted to CHO group in presence of palladium and barium sulfate. Okay, so this will become CH3CHO. CH3CHO. Another one, benzoyl chloride, COCl, on reduction with the palladium and barium sulfate, then this will give benzaldehyde. Okay, so acid chlorides are converted to aldehyde in the presence of palladium and barium sulfate as catalyst, which is poisoned with quinoline or xylene. So this reduction reaction is called Rosenmund's reduction reaction. So far we have discussed 3 named reduction reactions: Clemmensen reduction, Wolff-Kishner and Rosenmund's reduction reactions. So these 3 reactions are very important. Okay. Next reaction is Wurtz reaction. In Wurtz reaction, an alkyl halide is converted to a hydrocarbon. An alkyl halide is converted to a hydrocarbon when the alkyl halide is heated with the sodium in dry ether. This is the reagent. In Wurtz reaction, the reagent is sodium and dry ether. Okay, so here an alkyl halide react with the sodium in presence of dry ether to give a hydrocarbon, and the peculiarity of this hydrocarbon is it contains double the number of carbon atom present in the halide. Okay, hydrocarbon is obtained containing double the number of carbon atom present in the halide. This reaction is called Wurtz reaction. For example, methyl chloride CH3Cl on treating with the sodium, on reaction with the sodium in dry ether, 2 molecules of methyl chloride reacts with the 2 molecules of the sodium to form CH3CH3. Okay, hydrocarbon is obtained containing double the number of carbon atom. Here only 1 carbon, here 2 carbon atoms are there. So double the number of carbon atoms present in the halide plus NaCl, 2NaCl. Okay, this is called the Wurtz reaction. Fittig reaction. In Fittig reaction, an aryl halide is converted to a hydrocarbon when it is heated with the sodium in dry ether. Same conditions, so sodium and dry ether as it is there in Wurtz reaction. But here in Wurtz reaction, an alkyl halide is converted to a hydrocarbon, while in Fittig reaction, an aryl halide is converted to a hydrocarbon when it is heated with the sodium in dry ether. Here also the hydrocarbon contains the double number of carbon atoms than the aryl halide. For example, chlorobenzene is heated with the sodium in dry ether, gives biphenyl. Okay, biphenyl is obtained. 2 moles of chlorobenzene and 2 sodium reacts together and gives biphenyl. Okay, this one you can write as C6H5Cl in ring form or like this C6H5Cl on treating with the sodium in dry ether. Here 2, here also 2. So it gives C6H5, C6H5. Okay. Plus NaCl, 2NaCl. Here also 2NaCl. Okay. Next is Wurtz-Fittig reaction. This is a combination of Wurtz reaction and Fittig reaction. Here in this reaction, an alkyl halide and an aryl halide is heated with the sodium in presence of dry ether, gives corresponding hydrocarbon. Alkyl halide plus aryl halide in presence of sodium and dry ether gives the corresponding hydrocarbon. For example, methyl bromide plus C6-chlorobenzene or bromobenzene on treating with the sodium. This gives C6H5CH3. Okay, these two are eliminated and then C6H5CH3 is formed along with the sodium bromide, NaBr. Okay, so this reaction is called a Wurtz-Fittig reaction. So these are some of the organic 9 reactions. This is very important. So study the equations, write the equations and study it carefully. Okay, all the 9 reactions are very important. Thank you.